So we've got our aim, our equipment and our method all sorted out, and now we're interested in actually taking our results, doing the experiment, taking our results. What I've got here is a sample table of results from a level 3 paper, and I'll point out things which are part of the level 3 and which are only a part of the level 2, or well, everything that you do in level 2 is part of level 3, but level 3 has some extra things as well. Okay, so first of all, on the left hand side here you can see this is for an experiment. I think it's a mass on a spring or something similar. Might be a loaded vibrating blade, and we've got a mass that is being changed. Okay, so the mass is being changed, and as a result of the mass they're measuring a time. Okay, they're measuring a time. This is actually, if you can see from the top section here, it's this part, the time taken for 10 oscillations is what that is. And they're doing 3 trials, 1, 2, 3, and then they're taking an average. Okay, so if you are at level 2, the only other thing you have to do is find the time, which is the average time for 10 periods divided by 10 to get the time for 1 oscillation. So that's what that is. So in level 2 you have your independent variable, the one you've controlled. Don't worry about these plus or minus things if you're level 2. I'll explain them in a tick for level 3. So the mass, your trials, your average of your trials, and then your modified value to give your final reading. So this is what you're going to plot. You're going to plot here, and we'll do a separate video about graphing, but you're going to plot your mass independent variable against your time period, your dependent variable. Okay, so that's how you record your results. Now there's a couple of little additions. We've got the plus or minus bits here. I'll just circle those. So plus or minus for level 3 students and level 2 who are interested. Don't do this in level 2. It's unnecessary and a time waster, and it takes a bit more time to understand it than what we have here in the video to get to you. So level 3 students is a bit of a refresher. Make sure you check your notes from your class, from your teacher, from your book to understand these. This is the uncertainties. You have to make sure you have your uncertainties in there. Okay, so this is the smallest division on the scale. The person measures the mass on an electronic balance presumably, and this gives them the smallest uncertainty. You can see a couple of points here where they've put a dash. That means there was, let's see, I'm not exactly sure, because you can always do smallest division. Perhaps they were unable to be measured. Tell you what I would do, if you have a slotted masses that hang from a hanger, and they have usually a stamped value on them. So that stamped value is going to be what you would write down for the mass column, but then for your uncertainty, I think it's a good idea to use the smallest significant figure that is on the stamped value if you can't measure them. If you can weigh them on a scale, then you use the smallest non-flickering number as your uncertainty. If you can't weigh them on a scale, use the smallest value on that's stamped on there, the smallest significant figure as your uncertainty. Okay, so these ones I guess would have no uncertainty for some reason. I'm not exactly sure why. If you are adding multiple masses, so say 70 grams might be 50 grams plus 20 grams, then you've actually got uncertainty of 1 gram in each of those 2 masses. So this one here would probably read 0.002 if you were doing it that way. This is probably putting those masses on a scale and measuring them. So smallest division. Okay. You've also got your uncertainty in the measured, uncertainty in your dependent, that is, variable. So this is plus or minus half of the range of these values. So you do the maximum value, it's 3.69, minus the minimum value, which both of those are both the minimum, 3.65. Half of that is 0.0, well that range is 0.04, and half of that range is 0.02. And then going from here down to here, you divide by 10, so 3.66 goes to 0.366, and you do the same thing for your uncertainty. 0.02 goes to 0.002, so you've divided by 10. Okay, so it's very important that you include your uncertainties at every stage of this. If you know your uncertainty is the same for an entire thing, you can just write it in for entire variable, you can write it in the top there, so it could be m kilograms, and then in another brackets plus or minus 0.01 kilograms. What else? For both level 2 and level 3, you need to have the name. I would actually prefer to have mass M. They've written it up here, so there's a bit of a key, but you should have mass M and then the units kilograms. Time T seconds. T1, 2 and 3 is fine, they're just the trials, not too worried about that. It's pretty obvious if you have 3 values what that is. Comparing it to your method, it should be easy to see. Your average, add them all up, divide by the number that there are, and then your divide by 10, your time period, and your uncertainty in that. Now, often people get confused on to write what the units for their uncertainties are. Your uncertainties, and that's what that triangle is if you're a level 2 student and you don't know what it's talking about, your uncertainties have the same units as the value that they are the uncertainty of. So the time period has the units of seconds, the uncertainty time period has the units of seconds also. Okay, and you should take as many values as you can with the independent variable resources, which are masses in this case, that you have. Sometimes your higher masses might not give you reasonable readings because things twist or the motion becomes unsteady, likewise with the smaller. So if that's the case, you still have all of your values here, but you just make a note about which readings are suitable to use or not, and then you might just say I'm only going to use these values and plot them. Okay, so that's not all that you have to do for the results. The results table is vital, but there's also a whole lot of other things, and this is a sample of some of the things that I write up when I'm just sketching. These are rough notes to cover it. So some of the things I do, I'll just sketch the title. This is my very, very rough. And I did this for level 2 physics, but also included some info for level 3 physics. I've got sketches with labels and lines to show distance measurements. You can see that there. And I make bullet points as they occur to me of different things I need to keep constant and to be aware of. I've got my results table, same as what you saw up there, but a little bit rougher. This is just the raw data here. This is the raw data, and it's uncalculated. I haven't even calculated the average, haven't calculated the time for one, and dividing that by 10. So obviously I've used 10t as my thing there. Okay, what else have we got? You can see I've got a little note on the side there actually that these ones became unreliable. My graph showed that there was a deviation at this point, so I couldn't use this information to help me calculate the trend. And I'd have to speculate and talk about it in my discussion about why that might have become unreliable. If it was a vibrating blade, it might be because of the way I set that up, and when you get the heavier masses it twists the blade a little bit, affecting the motion. Okay, oh look there, see I've got a note here, hanger wobbled too much to use, so best range possible using slotted mass combos used. The best range is those above. Okay, and even more notes to myself, repeat an average and explaining why that does it. These are just little notes to myself. Countdown, I used a countdown there to help me to get the timing, starting and stopping, and it makes me wait until I'm into a stable oscillation. All these other little things. Possible source of systematic error, I noticed while I was using my rubber band, I didn't take the mass of that into account. And there we go, putting masses on twists or kinks the blade, that could affect elasticity. That's during the process. And any notes at all that occur to you. I've also got some spring constant calculations which are quite handy for level 3 in particular. Okay, all sorts of stuff that you can, all of the notes you put down, that's your results. Okay, observations you make in the moment, that's your results. I'll leave it there, you get the idea. Make sure you understand that table first, and then the rest of it second.